Okay, so in this lecture, I want to talk about necessary and sufficient conditions. Um, and so I don't think we use this terminology very often. We don't, unless we're philosophers or mathematicians or lawyers, we don't talk about necessary and sufficient conditions. We don't say that. But I actually think necessary and sufficient conditions are pretty important in legal reasoning and in moral reasoning. Um, so it's good to talk about them. And I think, understanding the conditional and how we can use the conditional to represent these will put us in a lot better position to think about what necessary and sufficient conditions are. And I think that will put us in a better condition to think about a lot of legal and moral principles. Okay, so let's start with a few examples, or rather, a challenge. Let's take these pretty common sentences and ask ourselves how we would symbolize them. Anyone born on American soil is an American citizen. Students caught cheating will fail the class. You can't win the lottery unless you play. And finally, you must be at least 3'8" tall to ride Space Mountain. This last one was kind of the bane of my existence when I was a kid. It wasn't Space Mountain, it wasn't Disney World. My parents would go to Dollywood a lot, and all the roller coasters there you actually had to be 4 feet tall to ride. And I still remember great landmark moment in my childhood when I finally cleared that line and could ride. I think it was the Blazing Fury, right? Um, anyway, very important, at least to young me, how in the world would you symbolize this? You know, political debates, what is, anyone born on American soil is an American citizen. Well, how do you symbolize that, right? Now, look, from the stuff we've talked about so far, from all that we have on the table, I'm going to guess this is a little challenging, right? All of these statements refer to groups of people, They don't, a lot of the stuff we've talked about so far, Tim will win the math prize, Jane will win the math prize, stuff like that. Those statements refer to individuals, and you can just symbolize those. You can sum those up with a sort of P means Pete will win the math prize or whatever. J means Jane will win the math prize. That's all fine for that, right? But when you have statements like this that refer to whole groups, whole classes that are much more general, well, how do you symbolize those? And how in the world do we even get at what these statements are saying, right? Are these conjunctions? Are they disjunctions? What's going on here? Well, I'll say in a minute, I think these all are best represented with conditionals. But first, we need to talk about how are we going to represent, or how best to represent, statements that refer to groups of people, or you might say in more abstract philosopher's language, classes, right? Or groups of things. It can also refer to groups of things as well as people. How do you do that? Well, first, let's complicate what we've been doing with symbolization just a little bit. We've had A, B, C, D. Well, another way to do this, and the way that we usually represent these statements that represent whole classes or groups of things or people, is with two letters, right? So here's an example. AX. A means X is an American citizen. Whatever we plug in here, means that is an American citizen, right? If we want to say Jim is an American citizen, we would say A lowercase j, right? BX means X was born on American soil, right? If we want to say I, Sam Duncan, was born on American soil, we might say BS, B little s equals Sam was born on American soil, right? So we can use this, big letter to represent this statement that applies to a general group of people or things, then a little case letter that mentions the particular person or thing, and that's a way to handle these statements that are much more general in what they say, right? All right. we still need to figure out, well, how do we represent this statement? And even though this statement doesn't use the if, doesn't use if then, it pretty clearly is a conditional statement, right? If you said, if X is born on American soil, X is an American citizen, you would say exactly what this sentence is saying, right? This statement is talking about the conditions to be an American citizen, right? Or a condition that means you're a citizen. So I think the best way to represent this is with a conditional, right? Well, what conditional will we use? Well, I think BX arrow AX, right? If X was born on American soil, then X is an American citizen. This represents that statement really well, right? If you're born on American soil, you're an American citizen. Well, BX born on American soil, AX American citizen, right? You know, if Joe was born on American soil, Joe's an American citizen. You might say B little j arrow big A low, smaller case j, right? Another way to put yet another statement, students caught cheating will fail the class. CX, X was caught cheating. FX, X fails the class, right? CX, arrow, FX. Hope this is all pretty clear to you guys why we're making these moves. Now look, all the statements we've looked at so far, students caught cheating and the American citizen statement, these are both statements that involve sufficient conditions. What is a sufficient condition? To say that P is a sufficient condition for Q just means if P is the case, Q is also the case, right? Anyone born on American soil is an American citizen. Students caught cheating will fail the class. This is just another way of saying being born on American soil is a sufficient condition for being an American citizen. Getting caught cheating is a sufficient condition for failing the class. Some other examples. If an anvil falls 20 stories directly on your head, you will die. If an anvil falls 20 stories directly on your head, then D, you will die, right? AX, an anvil falls from 20 stories onto X's head, arrow symbol DX, X will die, right? If the fans riot, the home team will lose the game. If your fans riot, that is a sufficient condition for your team losing the game. Now notice, all of these aren't saying this is the only way for this to happen, right? If you're born on American soil, you're an American citizen, but it's not the only way to be an American citizen, right? You can be naturalized, your parents can be citizens, getting caught cheating isn't the only way to fail the class. If you come in and take every test, but you fail those, fair and square, you're still going to fail, right? Sadly, getting hit in the head with an anvil isn't the only way to die, right? Okay. So, sufficient condition, P, sufficient condition for Q. P will get you Q, but of course it's not the only way, right? Well, how do we symbolize this? Well, it's pretty simple, right? Obviously, P arrow Q does a great job symbolizing sufficient conditions. P arrow Q, P is a sufficient condition for Q. Way we symbolize that is P arrow Q, right? And that works perfectly if you think about it, right? What this is saying, remember the conditional is only false if you have P but not Q. Well, what this is saying with this P arrow Q is anytime you have P, you're going to get Q as well, right? Now, remember, if the antecedent is false, the conditional is always true. And again, think about sufficient conditions. You're not saying that P is the only way to get Q. There are a lot of cases where you might have Q without P. Your team can lose the game even if fans don't riot. Plenty of ways to die besides getting hit in the head with an anvil. So this symbolizes all that perfectly. Okay, hopefully that is clear to you guys. I think it's fairly intuitive. Now, what's harder, at least initially, are so-called necessary conditions. Well, what are necessary conditions? Well, here's an example of a necessary condition. You must be at least 3 feet 8 inches tall to ride Space Mountain. So this is saying to ride Space Mountain, you have to be this tall. It's a necessary condition for being allowed to ride Space Mountain that you're at least 3 feet 8 inches tall. Well, how do we symbolize that? This seems like it involves a conditional too, but how do we symbolize it, right? I mean, look, obviously the statements here that this involves are pretty clear, right? Tx equals x is at least 3 foot 8 inches tall. Sx equals x. Excuse me. My allergies have picked this time to act up. Great to have your allergies acting up this particular time, but whatever. Sx equals x is allowed to ride Space Mountain. So these are obviously our two statements. We're going to put them together using a conditional. But how? What goes where? Well, you might think that we should symbolize this Tx arrow Sx, right? Well, that's not going to work though, right? What does this statement say? This says if you are 3 feet 8 inches tall, then you can ride Space Mountain. Well, that can't be right? I mean, think of it this way, right? It's not the case, and the statement never says it's the case, that we're going to let everybody who just happens to be 3 foot 8 or taller ride Space Mountain, right? If you were in a whole body cast and, your friends wheel you up in this whole body cast and they say, well, he wants to ride Space Mountain, they're not going to let you on, right? Even if you are 6 feet whatever, if you are obviously still recovering from a horrible accident, they're not going to let you on a roller coaster, right? I don't know that they serve beer at Disney World. I can't remember. But I know they do at Busch Gardens, and I've had friends who have misbehaved at Busch Gardens, and I'm going to guess if you're reeling drunk and throwing up on the sidewalk, they are not going to let you on the roller coaster, right? No matter how tall you might be. So again, that can't be what the statement says, that, well, just, if you're this tall, we're going to let you ride the roller coaster, right? That would mean that being that tall is a sufficient condition for being allowed to ride the roller coaster, but that's not what the statement says, right? And another problem with putting it this way is that it would still allow that there are possibilities you could ride if you're not that tall, right? This statement says if you're that tall, you're allowed to ride. It never says, well, if you're not that tall, you're not allowed to ride that, right? And that's pretty clearly what the original statement says. Well, so how do we symbolize this using the conditional? Well, pretty easy, right? We've eliminated one possibility. There's only 2 ways you can put these things together. So obviously, one way to symbolize it would be Sx, you can ride Space Mountain. Arrow, Tx, you are at least 3 feet 8 inches tall. And now think about that. That actually works, right? Given this condition, we know that if you're allowed to ride Space Mountain, you have to be that tall. Now, another way to put this, another way you might want to symbolize this, is just to say not TX, arrow, not SX, right? If you're not at least 3 feet 8 inches tall, then you can't ride Space Mountain. And, honestly, even though the original statement doesn't have any knots in it, I think 2 is probably the most intuitive way to get at this, right? What the statement is saying, if you don't satisfy this one condition, you are not at least this tall, you can't ride the ride, right? Well, 2 different possible ways to symbolize it. I've already said I like 2 a little better, but that's just my opinion, right? Which one of these is actually right? Think about this for a second. Which of these is the right answer? Right, it's a trick question. Remember the contrapositive, right? If P then Q is logically equivalent to if not Q, then not P, right? If you have this statement, if P then Q, P arrow Q means exactly the same thing for the purposes of logic as does not Q, arrow not P. So just for purely aesthetic reasons, I kind of like 2 better. That's the way I would symbolize it. You can use either because remember we define statements for the purposes of logic with the truth table. If they always have the same values on the truth table, then, logically equivalent, this little 3 bar sign, these 2 statements do. It doesn't matter which you use. So, P is a necessary condition for Q. You can symbolize that in one of 2 ways. Q arrow P or not P arrow not Q. Even though these statements don't say not, I prefer the latter a little bit more. That's just me being fussy. That's just a matter of taste. You can use either one. Just as long as you know P is a necessary condition for Q, one of these 2 symbolizations, Q arrow P or not P arrow not Q. Okay. So obviously this is going to be a little bit tricky, right? Symbolizing conditionals will sometimes be hard, right? Because think about this, right? Let's go back to our statements that we started with. All the way back. All of these statements, I would say you would symbolize with a conditional. None of them actually use this if-then language, right? Well, look, again, what we started the class with, thinking about what the person's saying, thinking about the intention. A lot of times, with conditionals especially, you're going to have to think, what is the logic of this statement? What is the person trying to communicate? And a lot of times, the grammatical form of the sentence or the literal words in it might not be a great guide to this, especially with conditionals. It can be a little complicated. We're going to spend a lot of time symbolizing conditional statements now that we have all this stuff on the table. Just be aware. That's one of the reasons I'm going to go through this so slowly, because this can be tricky. Okay, but the question, you guys, I think, now you should always ask in a class, is like, why is this important? Why do we want to talk about this necessary and sufficient condition stuff? Well, look, even starting next week, I'm going to spend a lot of time on moral and legal principles, right? I think those are really important with logic. Logic will throw some light on them. And I think necessary and sufficient conditions are vitally important when we think about legal and moral principles, right? We have huge debates in the US about citizenship. Well, That all goes back to the necessary and or sufficient conditions for being a citizen, right? If you are a lawyer, or even if you just sign a contract, you want to know what the necessary conditions for fulfilling the contract are, and you want to know what might be the sufficient conditions for fulfilling that contract, right? You want to be very clear on that stuff. And people have a tendency to mix up necessary and sufficient conditions. And you can get in real trouble if you do that. Think about a contract, right? If you misread the contract and it says, well, it's a necessary condition for fulfilling the contract that you deliver 500 pounds of mulch to this address by this date, well, if you think that's all you need to do, but actually it goes down and says, and you must do so by 12 in the morning, 12 p.m. Look, delivering it on time and delivering the mulch is a necessary condition. It's not sufficient. You might be in legal trouble if you're not clear on that, right? You might not get paid. Okay. But even more important, I'm not going to go too deeply into this. You guys didn't sign up for an applied ethics class, but I think this is a nice illustration. Like, this stuff about necessary and sufficient conditions is really going to loom huge in some debates about, say, physician-assisted suicide or abortion. We're going to talk about moral principles with conditionals next week and some arguments that are important with those. I'm going to use the abortion debate as an example just because there's some interesting arguments here. Hopefully you guys will find this interesting. You have an opinion on it about it, not just a boring abstract debate, right? Anyway, take two examples, right? When people argue about abortion, they argue, generally speaking, about personhood, right? Is the fetus a person? Both sides, both the pro-life and the pro-choice side, agree if something's a person, it has legal and moral rights. Their big disagreement is going to be, is the fetus a person, right? Well, this whole personhood question, which is going to be important for some other areas too, gets into necessary and sufficient conditions. What conditions are necessary to be a person? What are sufficient? And a common pro-life argument works with this idea of sufficient conditions, right? One common pro-life argument says being biologically human is a sufficient condition for being a person, right? The fetus is biologically human, it is a person. Fetus is biologically human, so fetus is a person, right? Guys can see the symbolization down here. BF, then PF, BF, so PF, right? On the other hand, an influential pro-life argument, this is actually a little more complicated than I have it here. We'll break it down more next week just to make the logic clearer. Works like this. It says, well, having the ability to reason is a necessary condition for being a person. The argument's actually a little more fine-grained. It breaks down what it says the ability to reason consists in. We'll just stay with the ability to reason for now, right? So, how would we symbolize that? PX, arrow RX, or I think a little better, not RX, then not PX, right? Don't have the ability to reason, then not a person. So if the fetus doesn't have the ability to reason, it's not a person, right? Second conditional just applies this much more general one to a specific case. Not RF, then not PF. Sorry, if not RF, then not PF. Fetus doesn't have the ability to reason, not RF, so fetus is not a person, not PF, right? Look, not trying to convince, these are very simple versions of both these arguments. We'll go into them in more depth next week, just to get a better idea of how we're going to use logic to make moral arguments. So whether you agree with them or not, that's not the issue. I just want you guys to see the very basic logic of these arguments and to see why this talk of necessary and sufficient conditions is really important. Okay, so hopefully that all makes sense to you guys. I have some homework on conditionals that I want y'all to do, just more practice now that we have everything on the table, symbolizing this stuff. We'll do some more practice. I'm planning on, I'm probably going to have a Zoom session going over. I think that might be the best way. For those of y'all who can't take part, I will then put the video of that session up. But anyway, this is everything I want to do on conditionals. Now we just need to do a lot more practice applying this stuff and also, seeing how it works, but also applying it to real world cases, giving us a better idea of how real life arguments function.